Okay, part two. Part two. I can't hold my phone up. That's okay. But we're getting the total resistance, which is this number. Not this number. This number. And we're getting the total current, which is this number. And you should check your math right before I go crazy and drop the phone. So, those are the two things that we were looking for to start with. All right, the total resistance, total current. Now, what we need to do is step through the circuit and piece by piece try to figure out what is the bit that goes everywhere. All right, is if we have this current and it flows somewhere, where is it flowing to? What is the potential difference on it? Right. Excuse me. So, I want to draw this circuit again. New paper. All right. This is the original circuit, so 20 volts. 30 ohms. 60 ohms. 15 ohms, 25 ohms. That's our circuit. And what we're going to do is step through, step by step, and ask where does this current go? And what is, every time we see a resistor and we know the current, we're going to find the potential difference, the voltage drop. And then every time that we know there's a branch, we know the potential there, and we're trying to figure out how the current splits. So when we start out, current goes this way, and there's 0.41 amps going that way. So we have from here to here what I'll call V30. And so V30, that equals I times R. Well, that's 0.41 amps times 30 ohms. And so V30 is, if I've done my math right, 12.3 volts. All right. So that means from this point to this point is 12.3 volts. That means this has to be the difference, because from here to here has to be 20. So from this point to this point, so V 75 ohms, which also equals V for the 25 ohms, that has to be 20 volts minus 12.3 volts. And that is 7.7 volts. Right? So we know from here to here is 7.7 volts. And so we know the current this way has to be V over R from Ohm's law, and that's going to be 7.7 volts over 25 ohms, and that is, so I'll call that I-25. This current is going to be 0.1 amps. And now we know the current this way, because when this current splits, whatever goes this way, well, I'll call I-75, and the current that goes this way, I-25, that has to end up being 0.41 amps. So this has to be 0.31 amps. Right? And we can figure that out. We can prove it. We can say that I, for the 75 ohm branch, that's going to be V over R, which is 7.7 volts over 75 ohms. And that's going to be 0.31 amps. And so we have this current, it splits up, 0.3 of an amp go here, 1/10 goes here. That works. And that makes sense. This is 3 times more resistance than this is. Is that right? I've screwed this up. I'm sorry. This is 0.1. And this up here is 0.31. See, what I'm doing is I've got cheat sheets where I've already calculated it, and I can't read them. So, you have to check in your mind. If this is 3 times the resistance, it should have 1/3 of the current as this one. And that's what happens. This should be 3/10 of an amp, and this one should be 1/10 of an amp. Alright, so finally, the last little bit, we want the voltage across this 15 ohm resistor. And so the voltage on the 15 ohm resistor is going to be I times R. It's going to be Ohm's law again. But it's the current that goes this way. And that's going to be our 0.1 amp times 15 ohms. And that's going to be 1.5 volts. And we can check the voltage on the 60 ohm is going to be I times R is 0.1 amps times 60 ohms, and that is 6 volts. I didn't actually write that out. 6 volts. And so there's a little discrepancy because I'm rounding numbers. As you're doing this, you should be getting additional decimal places that will come out right. But this gets us, you know, if I saw this, I would understand that you understood the circuit. Right. So that's what we're doing. And we're going to practice this more. But we're basically going through and saying, if we know a resistance and we know the current through it, that tells us the potential across it. And if we know the potential between 2 points and the resistance, we can work out what the current is through it. All right, and so we have to figure out how this stuff's going to divide out. Say goodnight to Francis.